All right, let's tackle a huge one today, a topic that has obsessed us for, well, forever: time travel. We're going to break it all down: what's real, what's maybe possible, and what's just pure science fiction. So let's get right into it.
This is it, isn't it? The ultimate question. The one that's kicked off 1,000 different stories, movies, and probably a few arguments. Can we actually do it? Can we hop out of the present and zip off to the past or the future? Well, you might be surprised by what physics has to say.
That's right, the answer is yes. Time travel is a real, scientifically proven, experimentally measured fact. In fact, every single one of us is doing it right now. The only catch? We can only go forward. And to understand how that works, we need to talk about the guy who basically turned our whole concept of time on its head.
To really get this, you have to completely ditch the old idea of time as this universal clock, ticking away at the same speed for everybody everywhere. It's not. Thanks to Albert Einstein, we know time is relative. It's all part of this four-dimensional fabric of the universe he called spacetime. And that fabric, well, it can be stretched and squeezed.
And the key to all of this is a wild concept called time dilation. It's a direct result of Einstein's theories, and it basically just means that time can tick by at different rates for different people. And this isn't just an idea on a blackboard, it's a real thing that happens in two main ways.
So path number one is speed. The faster you rocket through space, the slower you move through time. It's that simple. If an astronaut flew off at nearly the speed of light and came back, they would have aged less than us. They would have literally jumped into our future. Path number two is gravity. The stronger the gravity, the more it warps space-time and the slower time passes. This means, and this is wild, your feet are aging just a tiny, tiny bit slower than your head.
And don't think this is just some abstract math. It's incredibly real. Get this. In 2022, scientists took these unbelievably precise atomic clocks and measured a time difference between 2 points just 1 single millimeter apart. The effect is almost impossibly small, but it's there. It proves that traveling to the future isn't science fiction, it's just how our universe is built.
Okay, so traveling to the future, it's on the table. It's a thing. But what about the past? This is where things get a lot trickier. This is where we slam into a massive fundamental wall.
Physicists call this wall the arrow of time. It's just a simple observation that time only seems to want to go one way. And the main reason for that is a law of physics called the second law of thermodynamics. All it says is that things in the universe tend to get messier, not neater. Disorder, or entropy, always increases. You can scramble an egg, right? But you can't unscramble it. That one-way street from order to chaos is the arrow of time, and it's our biggest hurdle for going backward.
Now that hasn't stopped physicists from coming up with some pretty wild ideas for how to do it, on paper at least. We're talking about things like wormholes, shortcuts through spacetime, or even looping paths in spacetime called closed timelike curves. They're all mathematically possible, but, and it's a huge but, each one comes with a frankly ridiculous catch.
Let's just take the most famous idea, the wormhole. The problem is, to keep that tunnel in spacetime from collapsing on itself instantly, you can't use regular stuff. You need something else, something truly bizarre.
You'd need something called exotic matter. And this stuff, if it even exists, would be insane. It would have negative energy. It would have anti-gravity properties. If you tried to push it away, it would accelerate back towards you. You'd need it to literally prop open the wormhole. The big problem? We have never, ever seen any of it.
But okay, let's play a game. Let's pretend we solve the physics. We find a chunk of exotic matter and build our machine. Well, now we have an even bigger problem. A problem not of physics, but of pure logic. I'm talking about the paradoxes.
And here's the classic, the most famous one of all, the grandfather paradox. It's a perfect, inescapable logic loop. You go back in time, you stop your grandparents from meeting. That means you were never born. But if you were never born, then how did you go back in time to stop them? See? It's a contradiction that eats itself. It's a logical knot so tight, some physicists think it's just the universe's way of saying, nope, not allowed.
So how do you escape that labyrinth? Well, scientists have come up with two main ideas. The first one is the Novikov self-consistency principle. This basically says the past is set in stone. Sure, you can go back, but you can't change a thing. You can only do what already happened. The other idea, the multiverse. This one says you can change the past, but the second you do, you just create a brand new parallel universe, leaving your original timeline totally fine.
And then there's this one, which is just a pure mind-bender. The bootstrap paradox. It's not about changing things, it's about where things come from.
Imagine you take a copy of Hamlet, travel back, and give it to Shakespeare. He just copies it out, it becomes famous, and centuries later, you pick up that same copy to take back in time. So, who wrote Hamlet? The play is just stuck in a loop forever with no actual starting point.
So, you see all these massive problems. The physics, the energy, the paradoxes. This is exactly why backward time travel is still firmly in the realm of speculation. But it's also why it's such amazing fuel for storytelling.
And this is where you can really see the split between science and sci-fi. In science, a time machine needs cosmic forces. In the movies, it's a cool car or a phone booth. For a physicist, a paradox is a reason the idea might be impossible. For a screenwriter, a paradox is the entire plot. And that big scientific debate between one fixed timeline or many branching ones? Well, that becomes the #1 question in almost every time travel story. Can we change the past?
And really, this all leads to one huge conclusion. The biggest challenge here isn't about building a better machine. It's about understanding. We've basically hit the limits of what our current physics can tell us. The final answer doesn't depend on engineering. It depends on solving the single biggest puzzle in all of physics.
And that puzzle is called quantum gravity. See, we have one set of rules for big things like planets and galaxies. That's Einstein's relativity. And we have another set for tiny things like atoms and particles. That's quantum mechanics. The problem is, they don't play nice together. They contradict each other. A theory of quantum gravity would be the one theory to rule them all. And it's right at that messy intersection, deep down in the fabric of spacetime, where the answers about wormholes and time travel are hiding. Until we figure that out, we're really just making educated guesses.
Which leaves us with one last, really fascinating thought. What if all these impossible hurdles, the exotic matter, the paradoxes, what if they aren't problems to be solved? What if they're actually features, not bugs? Maybe they're the universe's own firewall, a built-in protection system, just to make sure that cause always comes before effect, and the arrow of time only ever flies one way.